Hello everyone. This video will be about just trigonometry. Question 5 of trigonometry, né? Because we are still trying to understand the basic part of trigonometry. Okay, 5.1. Before I start, please subscribe too. Yeah. Okay. 5.1. I'm given sine beta is equal to a third. And I'm told that beta can be found in the second or third quadrant. So firstly, sine beta is equal to a positive number. I must go and tick where sine is positive. Sine is positive in the second quadrant and the first quadrant, right? But I can only find my angle of beta in the second quadrant and the third quadrant. My right angle triangle will be always where I have the most number of ticks. So I'll have my right angle triangle. I'll have beta. Okay, by definition, sine is opposite over hypotenuse. So if this is 1, then this is 3. Then all I need to do is to find the adjacent side. Adjacent side is x. I know that x squared is equal to r squared minus y squared, which is 3 minus 1. This is 9 minus 1, and I have 8. So therefore 8 will just be plus minus the square root of 8, which will be 2 root 2. So this thing will be negative 2, or just let me just say square root of 8. It's fine. Just square root of 8. Okay, so I'm choosing to write negative square root of 8 because my right angle triangle is on the left hand side of the y-axis, and I know that on the left hand side of the y-axis x is negative. So now I have the values of x, y, and r, which simply means I can answer everything that I can answer every question I have. I know that x is equal to negative the square root of 8, y is 1, r is 3. Cos of beta. Cos is adjacent over hypotenuse, or x over r. Then they want me to find sine 2 beta. It's 2, this will be 2 sine beta cos beta, right? And this will be 2 times sine beta is 1 over 3, cos beta is negative square root of 8 all over 3, which is negative 2 or root 8 over 9. That's my final answer, right? And then for this one, I have an angle which is above 360. All I need to do is to just subtract 360 from that angle, and then I'll be left with the cos of 90 minus beta. Whenever I see 90 minus, I need to change to the co-ratio. Since 90 minus is in the first quadrant, I don't have to worry about the signs. Then I'll have sine beta, which is 1 over 3. Are we together? So this simply means that my answer here is negative 2 root 8 over 9, and then my other answer here was just 1 over 3. Okay, now let's move forward. I'm given that expression there, né? I'm supposed to show that this expression is equal to 1 minus sine. The first thing I need to do whenever I simplify the left hand side, because it's the most complicated one, né? I just need to take out the common factor. The common factor is just cos squared x. Whenever I take out cos squared x, I'll be left with cos squared x plus sine squared x over 1 plus sine x, right? So I'll be left with cos squared x over 1 plus sine x. I can change everything to have one trig ratio. Whenever I do that, I'll have 1 minus sine squared x 1 plus. If guys are struggling with proving identities, there is a video dedicated to proving identities there in the playlist. Please don't shy away from it. This thing will give me the difference of two squares there at the top, ne? I have 1 minus sine x 1 plus sine x all over 1 plus sine x. This will cancel this. I'll be left with 1 minus sine x. Then I've proven that the left hand side is equal to the right hand side. Are you together? Okay, now they want me to find the values. They want me to find the values of x for which the expression will be undefined. My expression will be undefined if and only if the denominator, which is 1 plus sine x, is equal to 0. Are you together? So I know that sine x is equal to a negative 1. My ref angle will be sine, then I'll get 90. I must only express my reference angle where sine is negative. Sine is negative in the third and fourth quadrant. In the third quadrant, we write angles as 180 plus the reference angle. So we'll have 180 plus 90, then we'll get 270 plus K360. In the fourth quadrant, we write angles as 360 minus. So we'll have 360 minus 90, we'll still get 270 plus K360. So therefore, I'll simply say x is equal to 270 plus K360, where K is an integer. Since I'm given a restriction like this, they do not only want me to find the general solution, but they also want me to find the actual values of x. That means I must substitute any integer values of x and then check whether is it within the restriction. I know that whenever I substitute 0, whenever I see k, I will get an answer whereby x is equal to 270 degrees. And this will be the only answer. Okay. 5.2.3, they want me to find the minimum value. Here. Okay, remember that this entire thing, y, is equal to this thing. So I can simply say, I mean, I know how to find the minimum value of something like this. I know that this graph will be between -1 and 1. I know. Are you together? But if I want to add a 1 so that I can have something like this, that means I must add 1 on the other two sides as well. Are you together? Because I want to have 1 minus sine x. So that means I must add 1 on the left hand side and 1 on the right hand side. Whenever I add 1 on the left hand side, I'll have 0. On the right hand side, I'll have 2. Are you together? So I know that now the function of y is between 0 and 2. So 0 will be my minimum, 2 will be my maximum. Are you together? So the minimum value is 0. Okay. 5.3. I'm given the compound angle for cos. Use the above identity to deduce the compound identity for sine. I want to know what is this thing equal to altogether, but for me to deduce that, I must use whatever that I'm given there. So I must try to make this sine a minus b to look like this thing, the compound angle. This thing can be written as cos of 90 degrees minus a minus b altogether, and then we can have the cos of 90 minus a plus b altogether. But remember that in our given identity, we don't have a plus between the two angles. We have a minus, so that means we must change that plus to have a minus, né? But it's easy because we know that a minus is made up of two negative signs, so this can be written as minus negative beta. I know that minus a negative beta is positive beta altogether, so I just wanted to change this to look like this, and then therefore I can simply apply my compound angle identity for cos. It simply says it will be cos of the first angle multiplied by cos of the second angle. Since I have minus there, I will have a plus. Sine of the first angle multiplied by sine of the second angle. This thing will just give me cos A multiplied by negative angles are in the fourth quadrant. In the fourth quadrant, cos is positive, so I'll simply have when I have 90 minus I must always use the co-functions, né? 90 minus is in the first quadrant, everything is positive there, so I'll just change to sine A, and then this will be cos beta plus I'll have cos A multiplied by a negative sine beta. Why is it negative? Because negative beta is in the fourth quadrant and only cos is positive there. So now I have sine A multiplied by cos beta minus, because of this guy here, cos A sine beta. So that means this guy or sine A minus beta should be equal to that. Okay, second question. I'm supposed to determine the general solution, né? They said to me, hence, even if they didn't, I can see that this is just a compound angle identity. I'm given this is equal to cos 2x. I'm supposed to find the general solution. Whenever you come across this word in maths, that they mean use what you just got previously or what you've just proven previously. I have sine of the first angle multiplied by cos of the second angle minus cos of the first angle rather multiplied by sine of the second angle. So this thing is just sine of 48 degrees minus x is equal to cos 2x. Altogether, I can change this. If I want to find the general solution, I can change this thing to like this. This will be the sine of 90 minus x. Now the trig ratios are the same. I can only express my angles where sine is positive. Why am I choosing sine? Because sine is the last man standing. I'm kidding. Sine is the trigonometric ratio which I'm left with. So I must only represent my general solution wherever sine is positive. I know that sine is positive in the first and second quadrant. So in the first quadrant, I'll simply have 48 minus x is equal to 90 minus x plus k 360. And then in the second quadrant, I'll simply have 48 minus x is equal to 180 minus 90 minus x plus k 360. Are you together? For this one, I won't get any solution. Will I? Oh, I will. This guy here, let me just write it in blue to show what I'm fixing a mistake. That means I also have negative 2x there. Sure. I think there's no solution. Okay. Whenever I take the x's on one side, I want to bring the x's to be on the left hand side. Ne? I already have a negative x, and then when the negative 2x jumps the equal sign to be positive, so I would have positive x is equal to 90 minus 48. That's 42 degrees plus k, where k is an element of integers. Okay, on this side I'll have 48 minus x is equal to this will be 90 plus 2x plus k 360. Whenever I take the x to the other side, I'll have negative 3x is equal to 42 plus k 360. Are we together? When I divide 42 by a negative 3, I'll get x is equal to negative 14 degrees plus k, where k is an integer. Please note that I don't have to change the sign of a period. I can just leave it like that. It doesn't matter. So these are my general solutions. If you're struggling with general solution, guys, there is a video on the playlist. Don't worry guys, I came prepared. X is equal to 42 degrees plus k, where k is an integer, or x is negative 14 degrees plus k 120, where k is an integer. So these are your two solutions. Okay, now I'm supposed to simplify the expression into a single trig ratio. The smartest thing to do here is to just change 3x into 2x. plus x, and then change the x into 2x minus x. At the bottom I will have 2, let me use a different color. I'll have 2 cos squared x minus 1. I already had a plus 1 there. Alright, together. So whenever I expand this thing, I'll have sine 2x cos 2x ne, plus cos 2x sine 2x plus guys, I don't know why I'm making so much blunders. I'm so sorry. This is sine 2x multiplied by cos x plus cos 2x multiplied by sine x plus sine 2x multiplied by cos x for the second one, and then minus cos 2x multiplied by sine x. This entire thing is divided by 2 cos squared x, because the ones have subtracted, right? So this guy will subtract with this one, and then I'll be left with the same things multiplying one another, which is 2 sine 2x cos x all over 2 cos squared x, right? This will give me 2. The sine 2x, I know it can be written as 2 sine x cos x multiplied by cos x, like this, still all over cos squared x. This will give me 4. This will give me 4 sine x multiplied by cos squared x all over 2 cos squared x, right? So this will cancel this one, and then 2 goes into 4 twice, and then I'll be left with 2 sine x. So this thing, whenever it's simplified to 1 trig ratio, is equal to 2 sine x. Thank you for your time, guys, and thank you for coming back and giving us your attention. I really hope, guys, that whenever you come here, you just learn a thing or two. I really hope that. Stay tuned, guys, and wait for more videos. I hope you all are preparing for your final exam properly. Thank you.